CEO of Innova Space Argentina. Thank you for being here with us in the PocketQube workshop. First, thank you very much for this invitation to event today. Thank you, Tom and Caius and all the team of Arba Orbiter for giving us the space again for the second consecutive years. I invite you to know the future. This presentation I will talk about our PocketQube MDQSAT 2P, design and develop of the Constellation for agriculture. The contents of our presentations are introduction, system overview, power subsystem, onboard computer, communication subsystems, and future works. Okay. All started a year ago when I met with my friend in Scotland, and I could see that the future was literally in my hand. So since I came back from Scotland, I worked hard with my team to develop a ready platform to be able to bring IoT communication to the world. In this way, I want to tell you what our mission is about. The platform name is MDQSAT, elaborated by our company Innova Space. And the name of the Constellation mission is the Libertadores de América. Innova Space mission is democratize access to IoT connectivity for everyone, starting with Latin America. We believe that with our satellites, we will revolutionize the Latin America IoT market. Our idea is tourniquet solution for agriculture in particular, moving from the end device communication, cloud, and dashboard for any application. Here you have some milestone. The first start activity with the amateur projects at Arduino with my students here in Argentina. And later the 2018 developed the first functional MVP Arduino. You can see in the picture. And we traveled with our team to the workshop in Scotland. And this year, 2020, we are accelerated by a Neutron, started accelerator here in Argentina by amount around 75,000 US dollar. And this month, maybe in November, end of the manufacture the first satellite assembly here in our laboratory. Sorry. In this time of the COVID, we have made many joint work agreements. In these reasons, have many alliance. For example, with Iran, with FASA, with my big friend Sahat, that talked before of me. The big project that the name is Project Amah. Sahat talked about it. The other agreements very important for us is, for example, Modco company, Brazilian company, developed our IDCS systems and have signed the agreement with a PocketQube for the propulsion system for the next generation of the MDQSATs. And signed many agreements with the US company that provide the first launch for us. And this is a a recent news it's very happy for us. The state of Argentina subsidized for más de $250,000 and chosen the best technology project in our country. the plan for the next year is to launch the first satellite of the constellation of 100. Okay, let me show you uh, our overview about general architecture of our satellite. You can see here a general block diagram. It shows the OBC as the center of the computer. Sorry, I can. That's okay. In the center of the computer, connected with a SD memory card, the S-band radio for payload communications. That you have electric power subsystem, which has 3 solar panels and 2 battery. You said a solar panel made for Azure with heritage in space. And you have a DCS control, VHF, UHF radio for TT and C, and other slot in case we need to add additional payload. Here you can see the 3D model of the engineering model, which will be assembly in the few weeks in our laboratory here in Argentina. You can see the future of our power subsystem. No surprise here. This power subsystem have the popular using HPB 1040, which has while used in previous CubeSat and PocketQube missions. So it is flight proven. Uh, Proven, sorry. It has a standard 16 pin header, and that can be regulated from 3.3 to 5 volts. All components work with the Texas Instruments. This is very important for us. And it can handle 3.3 watts. This is uh, um, on power subsystem. This is an analysis that we make. As for the power generation, we studied 4 different configurations of the solar panels. In the graph, you can see the mean power generation for each configuration according to the orbit. Because our mission will be fly as a big bag, we don't know for sure which will be the orbit parameters. And the power generating is strongly dependent on the orbits. So we simulated several sun-synchronous orbits with the different local time of the sense nodes. The chosen configuration is the one shown in the mesh, which can generate between 1.3 and 2.7 mean power. Onboard computer. Here is one of the many OBC that I think in our architecture. This is the family microchip, SAM-D, 32 bytes with standard PocketQube. Have a magneto-resistive memory in all aspects. Your micro SD card slot have magneto-resistive memory. In the communication have Texas Instruments insulator for all communications, you can see, and support all language for programmation, for programmer, sorry, the C, C++, Python, and Arduino IDE, maybe. You can see the shell of aluminum isolated. And communication subsystems This mission will be count with the telemetry and telecom and radio and payload communications. The bands defined are VHF and UHF bands for TT and C, and S-band for payload communications. The shells are recomposed for rainy days aluminum isolated, and the other details are still in the definition process. Okay, the future works. Finally, let's talk about future work. As the part of the execution plan, we will develop the first low-cost IoT satellite architecture in Latin America to give access to satellite communications applied to the agriculture in essence. Our main challenge, milestone, you can see there, in 2022, finished a prototype primary test. In 2021, assembly all satellite and launch in the last of these years. In 2022, develop the 3 satellites of this platform for the trial and test. And 2023, launch these 3 satellites. And later in 24-25, launch of 10 more for the Latin American coverage. And maybe surely that one of our next step will be to open regional office in Peru, Chile, Mexico, USA, and Barcelona. This is the next step for the next years, sure. Thank you very much. Thank you for your attention. Stay here for any question.